So when you do your graph, what you're gonna do is, whatever software you're using, you're gonna plot the data points, do a scatter plot. And so it will plot the points, whatever they happen to be, and then you'll say add trend line. So the trend line is put on top of there based on the data points that are already there. And so, now, from a science point of view, especially on the second graph, you got two right here. There tends to be, looks like a general trend going up and to the right on the second graph, and yet you got one of those points just seems like it's way off. So if you were looking at that, that would be the one where you go, huh, I wonder if we should redo that. Now, within the context of the lab, you might not be doing the graph till after you've left, and redoing it is not necessarily feasible. But if you were, say, getting ready for publication, you would find those outliers that go, let's make sure we understand what's going on there. All right, now, I will say that the graph on the left is fine. However, the graph on the right here, I would give 2 out of 10 points for it.
Do they need to be going up by the same number on each axis?
They're not labeled.
That's the big thing. In terms of that, as long as you're consistent on that axis and then consistent on that axis, they don't have to be up by the same increment on both axes.
I'm saying like between the two graphs, like are these?
Oh, no.
No.
They just happen to be the two graphs. The lab you're doing next week, you'll make 2 graphs, and it's just whatever. The numbering system on the sides is automatically done for you.
They don't have to correspond with two
No,
separate
no,
graphs?
they are 2 independent
Okay.
parts of the experiment. Amy, you said?
Oh, the y-axis and x-axis aren't labeled.
Yeah. They left some stuff off of this one. So the labels, and also what else was missing besides labels?
Units.
Yep, labels and units. The next one. One of these graphs I would give full credit to, the other graph I would take off 20% on. Which graph has all the things that you need?
The left one,
Okay. Then what's missing on the right-hand side?
units for distance.
Yep. You know, it's fine to do a comparison here, but it makes a huge difference whether that distance in centimeters or meters. And, there we go. Page 5. One of those graphs I would give full credit to, the other graph I would take off 10% on. Though if I were really ticked, I would take off 2 points on that other one instead of just 1 point out of 10.
For me, I would say the left one at the back,
The left one is good or bad?
bad.
Bad, all right, so that, okay, so what's wrong with this one?
For me personally, it would be the fact that, the circumference on the left is like centered.
That is actually something that I don't take off for that one,
Okay.
but that,
For me, that would bother me.
yeah, and that's the kind of thing that over time, now that I see it, it's gonna bug me.
So it's not that though, okay.
Yeah, that's not something I take off for, however, if you're getting ready for publication, you probably
Yeah.
would wanna fix that.
Because the time squared on the right is just s to the second power.
Oh, the units there?
Yeah.
No, if I had you to be doing, if you were gonna be doing a formal report, that's the kind of thing where I would take off for it on a formal report. But the once a week lab that we're doing here, I actually don't take off for that either.
Okay.
Just because it can be a real nuisance depending on what software you're working with to be able to fix that. Sometimes I get it the first try and sometimes, about the 5th time.
Is it because they got, your distance in point 1, point 2, point 3, instead of saying another measurement other than meters, say,
No, I have no problem with the decimals there,
okay,
because it is in meters, 0.1 meters, 0.4 meters, those are all legitimate.
okay.
Okay, just to be clear, so like the increments on the distance and the beginner squared can be different as long as they're consistent?
Yes,
Okay.
yep, no problem there.
Is the left one just too perfect of a straight line? Oh, there's no,
Oh,
like on all the other graphs, points are off a little bit.
if all the points are on the line, there is a certain suspicion there. What I then looked at, because when you said that, I thought, oh yeah, that could be an issue, because that, oftentimes you get that kind of perfection if they have not measured circumference and diameter separately, but they measured diameter and then calculated circumference, in which case you should get perfection. The next thing I looked for was the slope of it. The slope should be pi here, and the slope is not pi, so I suspect those were the actual measurements. That whoever did this, whatever group that was, they took very special care to make sure that they did it consistently. So all the points on the line is a cause for suspicion, but in this particular case, I think that's okay. Matter of fact, I had one group that was getting perfect results, and they called me over just to make sure that I was aware that they weren't, forcing perfect results. Those are the actual measurements they were getting. So the problem, there is actually a problem with the one on the right. So we've got the scatter plot, good. Some outliers, but there are a lot of reasons for that. Got an equation, got an R squared value, all that's good. Got labels, got units, looking good. Got a title here, and the first word in the title matches the vertical axis. Second word in the title, or the distance, matches the horizontal axis, all that's good. Now what did you learn in elementary school about writing titles down?
Capitalization.
Yep. Time and squared should be capitalized. They capitalized them for the label, just not for the title. And I have 3 circles here. Oh, and squared probably should not be in parentheses. All right, next ones. So we're on page 6 here. I've got one issue with the graph on the left, and I have 3 issues with the graph on the right. So I'll start with the one on the left.
Grid. There's like lines right here, but there's.
Oh, I'm okay with that.
Oh,
I would say the placement of the numbers on the lines,
I actually,
you don't care about it?
it looks awkward the way it is. I actually don't take off for that.
Okay.
So I'm coming with all sorts of great ideas for like additional things. No. I'll subject the next group to it so that this group doesn't hate you. All right. This one, if you've gone through about how to do a proper graph, then I would expect somebody in here to know it. In this one, don't put graph 1 down. I want the graph. I don't care if it's the first graph or the second graph. The title should just be circumference first diameter, not graph 1, circumference first diameter. Same issue on the second one. They should not be writing graph 2. All right, so on the one on the right, there are 2 issues. One is actually serious, that it's wrong, and the other one is sort of along the lines of, it really bugs me, the way some of this other stuff was bothering Brandon. This one's bothering me.
didn't they not, for the S, they didn't put the square?
Yep, That's one of them right there. That's the one that's just wrong. Now, the one that's bothering me,
What was that? I didn't hear.
Yeah.
Oh. that's it.
Oh, the S isn't squared for the times squared.
Yep.
Is it just that they continued the line all the way through
Yeah,
the draft?
yes. That, there's no reason to extend the line all that far. Excel will automatically, when you do add trend line, should be linear, and then you check the two boxes to show the equation and the R squared value. You don't need to fix anything else in there so that it extends the line one way or the other.
Would you want us just to stop it at the x-axis?
No, just whatever the default is, just let Excel
Okay.
do its thing, or OpenOffice. Let's see, that was 6. 7. Oh, yeah, I would, on the one on the left, I would take off 5 points, and the one on the right, I would take off 4 points.
Equalization of both.
Which one are you talking about?
Both of them. And on the one, like the one on the right is in all caps on one, and then just all lower caps, or lower case in, like for the distance.
Okay, all right, so what should be capitalized and what shouldn't be on the one, we're on the one on the right?
Okay, so just the first letter should be capitalized,
Okay, first letter of,
each one.
yes, all right, so distance should be capitalized, there's a point there. Average time squared, don't do all caps, don't shout at me. The A, T, and S should be capitalized for average time squared. So that's 2 points right there for the one on the right.
No parentheses around square.
Yep. Units should be in parentheses there. Ooh, I should have taken off 2 points for that. Because the S should be lowercase for seconds, not uppercase, and it's missing the parentheses. Another capitalization issue in the title. The T and the S, I suspect. This is the lab partner for this guy over here. Yeah, they were lab partners. So the T and the S should be capitalized and the parentheses shouldn't be there. The one on the left,
For the one on the left,
Is it because it says and instead of versus?
yep, there's 1 point right there.
and is it the order in which, like, the title is in?
And that's another point right there. Should be circumference versus average diameter or first diameter. The first word in the title should be the vertical axis or the dependent variable. And then an issue that Madison mentioned for the other one.
Okay.
Yep. They did all lowercase for the labels.
Yep.
Why? I don't know.
What about the bolded line?
I made a note of that. I wouldn't actually take off for that because I can see the data points that are being used. The thick line there is unnecessary. If I were to, realistically, if I'm grading this and I'm in a bad mood, I probably would dock that. And that's the kind of thing that, if I did that to you and something that is sort of capricious, just come up to me and say, why'd you take off this? Is there something where you've written down that I'm not supposed to do a line that thick? And,
Were you in a bad mood?
yeah, I mean, you can do that too. Now, sometimes, sorry, I'm not gonna go down that path, never mind. All right, next one, page 8. The one on the left, I would take off 4 points. The one on the right, I would take off, 10 points. The person would get no credit for the one on the right. But I would only take off 10 points as opposed to, if I would have taken off more points than the 10, graphs are usually worth 10 raw score points. So if I had taken off 10, I would have told you, but I would have taken off 10 points for the one on the right, 4 points for the one on the left.
They don't have the R squared,
And,
and the one on the right doesn't have a line.
all right, and they're also missing
Slope,
Equation,
the equation. You said slope?
yeah.
Yeah, the equation more specifically. Also, considering all the points are lined up like this, I would take off for this elsewhere. There's something seriously wrong with this data here. There's no reason, because in this particular experiment, you're rolling a ball down a ramp and you're timing how long it takes to get there. The fact that they're saying that they rolled it all from the same place and the times varied from a little over 2 seconds to a little more than 15 seconds, yeah, there's something seriously wrong with the data. So I would go back over to their data and results and probably dock them for something there, because if these are the results that they got, they did not follow the directions. All right, nearing the end, number 9. I will spoil this one for you. I would not take off any points. There is one area where if I did take off a point, I would, in the fact that the units on the right-hand graph, the units on the vertical axis, they have S2 instead of S squared. Typically, if you want to do an exponent without having to go through the formatting, do the caret, like you saw in the previous one. Formal report, I definitely would take off for that, but on this one right here, I understand what they're trying to do there. And 10, the one on the left, I would take off 5 points. The one on the right, I would take off 4 points.
No units on the left one.
Yep, there's 4 points right there.
Spelling,
And
spelling.
yes, the one on the left misspelled acceleration on the title. Did not misspell it on the label though. You know, there's a certain amount of, they misspell it both places, I'd take off for both, but there's a certain amount of, at least they're consistent. Years ago, I had a student who misspelled encyclopedia and spelled it 3 different ways. I had another student who was writing experiment a whole bunch in the part of the lab, spelled it actually experiment instead of experiment. 34 times misspelled it. At that time, took off 1 point for every misspelling. And then, so the person starting out with, I guess a 64 on out of 100 points. In that case, I handed it back to him. I said, correct all of them, and I'll just take off 10 points for the nuisance. And then, the very last one, page 11, the one on the left, you have that S2 issue again. Preferably that would be S squared. But I did not, at least when I was looking at this, did not take anything off of that. But the one on the right, I took off 2 points for the one on the right.
Spelling on the right.
Ooh, I missed that one. Which one?
Across the y-axis.
For the one on the right?
Yeah,
They missed it.
acceleration.
Oh, yeah. Another point there. Oops. They spelled it right on the other graph. Okay. All right, so there's 2 more points that I would take off for. And this just might be a matter of, format-wise, there's no problem with the format. There's a problem with content.
Mass isn't measured in newtons.
And reciprocal mass isn't either. Yeah, that's the, newtons is not a unit of mass or reciprocal mass. Newton is a unit of force. What is the SI unit for mass?
The gram. Is it gram?
Right. That would be the older, so the CGS system. In the MKS system, what's considered standard, you're close.
Kilogram?
Yeah, kilogram. What is the proper SI unit for weight? No, not, slug is US customary mass. Well, I'm glad no one gave me the really wrong answer for that one. The SI, the standard international standard unit for weight is newtons, which is what a person had right there. Weight should never be in kilograms. Never. I know biology people do it, but if you're ever with a biology person and they use kilograms for weight, look at them, give them the eye. Look of disgust might help. All right, questions before we get back to the thing that I skipped last time because we didn't have enough time. All right, do a quick review. This denotes what?
Distance?
No. Distance is the scalar first off, and this is the vector.
Displacement?
No, but you're closer.
Velocity?
No, not with an X.
What did you ask me, Brian?
What is this denote?
Like, position?
That's the one, position. Delta X.
What is it?
Yeah, that's the swing.
Velocity.
Acceleration.
I think you said it. All right, so these are the big four, what I will reference as the big four. At the end of class, we were developing the math relationships between them, but I want to get back to what we were doing before that with a plus minus zero. So plus, I guess zero minus, put it in some order there. Position is where object is with respect to zero, or the origin, or generally it's called zero in one dimension, 2 dimensions, it's called the origin. So it's positive if on plus side of 0 for one dimension. Displacement, where object is with respect to the starting point. So it's positive if on positive side of starting point. Velocity. How fast an object is going. And in what direction. And it is positive if going in positive direction. So when we go through the exercise, when I'm talking about displacement, this is overall, I shouldn't have to say overall, but just at this point, we're still working on the language. This is instantaneous velocity, and this will be instantaneous acceleration. Acceleration, the rate at which velocity changes. And the positive is a little bit harder. So positive if total force is in positive direction. That's at least a simple way of expressing it, even though we haven't talked about forces really. Or the other way of looking at it is speeding up, same sign as velocity, and then slowing down, opposite sign as velocity. And let's see if I can pretend to write that more neatly. So if you're forced in the direction that you're going, so if you're walking along and someone pushes you, you will speed up. When they push you, they push you in the same direction that you're already going, so you will speed up. If you're slowing down, if you're pushed opposite the direction you're going, so I'm going to the right, I'm pushed to the left, it will slow me down to start with. Let's make 0 there. Let's make this my starting point. And let's make to the right positive. We're gonna do the plus minus 0 in unison would be absolutely spectacular. So right now, my position, I heard, it sounded like one voice, it was that good. Let's see if we can get a little bit louder though. My position,
Positive.
my displacement,
Positive.
yeah, because I said my starting point's over there. My velocity,
0.
my acceleration,
0.
all right? I start to move in that direction right there. As I'm starting to move, my acceleration,
Negative.
Positive,
why positive?
because that's just how, like,
Your speed,
your-
yeah.
Yeah, your speed. Or,
Speeding up says it's gonna be the same sign as my velocity. If I'm going in that direction, what's my velocity?
Negative.
If I'm speeding up in that direction, then my acceleration is,
Negative.
it is negative. Or in order for me to go that way, I have to be forced in that direction. If I push that way, I'm not gonna suddenly start going that way. So it is indeed negative acceleration. My position,
Positive.
why?
Because you're to the right of your starting point.
That would be displacement then.
All negative.
0 is over here. Position's negative, displacement's positive. All right, so let's. All right, velocity,
Negative.
acceleration
Negative.
is, I was trying to get a constant velocity there. Was I speeding up or slowing down as I was walking that way?
You were staying about the same.
Yeah, so acceleration should be 0. No change in velocity, acceleration is 0. All right, so what we're gonna do here is I'm gonna give you what I'm gonna call a basic problem. And then after we do that, and you'll work on it on your own or, you know, as carefully as you can with someone else if you need to. And then we'll do a test level problem. So ball is thrown up into the air. It's gonna go up and then come down. It's a one-dimensional problem, even though I've drawn it, what makes it look like it's coming down slightly off path. I'm doing that just because of the drawing. If I actually drew the path of the ball, it would be that, which is not necessarily clear. Ball is going up and coming back down. Just, all we're cared about is the one-dimensional motion. I'm gonna say up is positive, and I'm gonna make 0 is the ground. There are 4 key moments in the path of this ball. There's point A, B, C, and D. Those are all moments in time, so let me define what those are. So A, time just after the ball leaves the hand. So the ball's already in the air when the problem starts. This is when the problem starts. B, the time the ball is at the peak, times C, C is the time when ball is at the same place it was at time A, but acting in opposite direction. Sorry, not acting, moving. I guess I'll say just moving down. So at time A and time C, the ball's in the same place, just at time A it's going up, time C it's going down. And then D, just before the ball touches the ground. Let's see if I can do this, how quickly I can do this. All right, so ball. So time A just after I release my hand, so A, B, C, D. I was a little bit off, hopefully you get the spirit of what's going on there. Unfortunately, it's being videoed and a good bit of it was out of view, so good use of video. The problem begins just after ball leaves hand. The problem ends just before ball touches the ground. Now, questions before I talk about notation? There are several different ways of expressing this. In the master set for chapter 2, I'm assuming one way that it's going to be presented. On the test, what I've done in the last couple semesters is I've given you a choice of 4 different ways of expressing the exact same thing, and you just pick which one works for you best. I'm going to talk about specifically the one that, especially if you're looking at the older tests, how those answers will be presented. So if something happens from A to B, so between